Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled RL Algorithms, Policy Gradients and Actor-Critic Methods, Advanced AI Decision Making. Hello, future AI developers. Ever wonder how AI systems make smart choices? Like deciding the best move in a game or how a robot should navigate a room? Today, we're diving into the heart of advanced AI decision-making using something called reinforcement learning. Think of it like training a digital agent. Much like you'd train a pet or learn to play a video game. It tries things, gets feedback, and learns what works best to achieve a goal. No prior AI knowledge needed, we'll build from scratch. At its core, reinforcement learning, RL, is an AI technique where an agent learns to make decisions by interacting with an environment. It's like teaching a puppy a trick. The puppy, agent, tries different things, actions, and if it does something good, it gets a treat, reward. If it does something bad, no treat, or a mild correction. Over time, the puppy learns the best actions to get more treats. In code, you're designing this agent and the environment it lives in, defining what actions it can take and what rewards it receives. In RL, the agent's strategy, or rulebook, for deciding what to do is called its policy. Imagine you're playing a new video game. Your policy would be your current plan. If enemies are near, shoot. If health is low, find cover. The goal of our AI is to learn the best possible policy to maximize its total rewards. As a developer, you're essentially trying to create a function or a neural network that, given the current situation, state, tells the AI the best action to take. So, how does the AI learn this best policy? One way is through policy gradients. Think of it like playing the hotter, colder game to find a hidden object. You try a direction, and if you get hotter, more reward, you know you're generally going the right way. Policy gradients directly adjust the AI's policy. If an action led to a good reward, the policy is updated to make that action more likely in similar situations. If it led to a bad reward, the action becomes less likely. It's a direct trial and error approach, nudging the policy in the direction of better rewards. While simple, policy gradients can be inefficient. Imagine you're cooking a complex meal. You only know if the final dish was good or bad, but not which ingredient or step specifically made it better or worse. This delayed, or sparse, feedback makes learning slow. The AI might take many actions before it gets a reward, making it hard to figure out which specific actions were truly responsible for the outcome. It's like trying to find the peak of a mountain in the fog, only getting a hotter signal after a long walk. To solve the vague feedback problem, we introduce actor-critic methods. This is where our AI agent splits into two parts that work together: an actor and a critic. Think of it like a director, actor, and a movie reviewer, critic. The actor is like the policy gradient agent. It decides what action to take. The critic, however, evaluates how good that action was or how good the current situation is. It gives immediate feedback, even before the final reward is known. This helps the actor learn much faster and more efficiently. Here's the magic. The actor proposes an action based on its current policy. The critic then steps in and gives an advantage score, essentially saying, that action was better, or worse, than what we usually expect in this situation. The actor uses this specific, immediate feedback from the critic to adjust its policy. Instead of waiting for a final distant reward, it gets a helpful nudge right away. As developers, we're training two AI components that learn from each other. The actor learns how to act, and the critic learns how to evaluate actions. leading to much more advanced and efficient decision-making for our AI systems. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.